If you ever find yourself gazing at falling snow, why not catch a few snowflakes on your glove and examine their shapes? You might notice that they look symmetrical, and if you look closely, you'll see they have 6 sides. You could say a snowflake is simply frozen water, but compare one with an ice cube from the freezer, and you'll realize they're very different things. Unlike ice cubes, formed when liquid freezes into a solid, snowflakes form when water vapor turns straight into ice. But that still doesn't explain why snowflakes have 6 sides. To understand that, we need to delve deeper into the physics of water. Water is made out of 2 hydrogen atoms and 1 oxygen atom. A single water molecule thus has 10 protons and 10 electrons, 8 from oxygen and 1 from each hydrogen atom. The 2 electrons from oxygen's outer shell are shared with 2 electrons from both hydrogens as they bond together, and the remaining 4 outer shell electrons from oxygen form 2 pairs. We call the bonds between these atoms covalent bonds. The pairs of electrons are all negatively charged. Similar charges repel, so they tend to stay as far away from each other as possible. The pairs form 4 electron clouds, 2 of which are where the hydrogen and oxygen share electrons. The repulsion between the unbonded pairs is even stronger than repulsion between the shared pairs. So the 2 hydrogens get pushed a little further to an angle of 104.5 degrees. The water molecule as a whole is electrically neutral, but oxygen gets a larger share of electrons, making it slightly negative and the hydrogens slightly positive. Due to its negative charge, the oxygen in one molecule is attracted to the positive charge of the hydrogen in another molecule, and so a weak bond between the 2 molecules, called a hydrogen bond, is formed. When water freezes, this bonding occurs on repeat, ultimately forming a hexagonal structure due to the angle between hydrogens and oxygen within each molecule. This is the seed of a snowflake, and it retains a hexagonal shape as it grows. As the snowflake moves through the air, water vapor molecules stick to the 6 sharp edges and expand the snowflake outwards, bit by bit. A snowflake's developing shape depends on atmospheric conditions like humidity and temperature. As a snowflake falls, changes in weather conditions can affect how it grows, and even small differences in the paths 2 snowflakes take will differentiate their shapes. However, since conditions at the 6 sharp edges of one snowflake are similar, a symmetric snowflake can grow. Weather conditions affect snow on the ground as well. Warmer ground temperatures produce a wetter snow that is easier to pack because liquid water molecules help snowflakes stick to each other. Melted snow also plays a critical role in another wintry activity, skiing. Completely dry snow is very difficult to ski on because there's too much friction between the jagged snowflakes and the ski surface. So what's happening is that as skis move, they rub the surface of the snow and warm it up, creating a thin layer of water, which helps them slide along. So technically, it's not really snow skiing, but water skiing. But it is true that no matter how hard you look, you're almost definitely not going to find 2 identical snowflakes. And that's a mystery that scientists are still trying to solve, though we know that it has to do with the many possible branching points in snowflake formation and the differences in temperature and humidity. And while we wait for the answer, we can enjoy watching these tiny fractals falling from the sky.